Okay, so today we're going to talk about the law of syllogism. And this is what the law of syllogism states. We're going to have two conditional statements. So, and I think we've grown accustomed to this notation here. P implies Q means if P, then Q. Right? So it's saying if we have a P implies Q and a Q implies R, it's very important when you're looking at law of syllogism that the conclusion of the first conditional and the hypothesis of the second conditional match. All right? And for that matter, it doesn't even have to be the first and second. This says Q implies R and P implies Q. It doesn't matter what order these things are. If you have an if leads to a then, and that same then leads to another then, right? So a conclusion matches a hypothesis. That's what we're looking for. So that's the order we should consider these things in. If both of these things are true, we can logically conclude that P goes to R. All right? That's the law of syllogism. Okay, so here's an example of the law of syllogism getting used. It says, if I study, then I get tired. So we have this conditional statement, which is probably true, right? Studying makes us tired because our brains are working, wears us out a little bit, right? That's why you should study before you go to bed. It makes you tired, you sleep well, ready for the test the next day or whatever you're doing. All right, but if I study, then I get tired. You'll notice that we're assuming this to be true, all right? And if it continues to be true, then we look at the second statement, if I get tired, then I go to bed. So conditional statement 1 says, the P part, I study, leads to the Q part, I get tired. The second conditional statement has the hypothesis, I get tired, which matches the statement here. It doesn't have to match word for word, it has to match in meaning. So if I am tired, you know, it doesn't have to be exact wording, but just it has the same basic meaning of it, right? But again, conclusion 1 matches hypothesis 2, then I go to bed. The logical conditional statement that should be true off of both of those is, if I study, if this thing happens, then the last thing should happen. I'm going to go to bed. All right? And you can do that through any number of if-then statements. You could have like several, like 4, 5, or 6 of these. How about, if I get a job, then I make money. If I make money, then I'm going to make plans with my friends. If I make plans with my friends, I'm going to go do something with my friends. If I go do something with my friends, I'm going to pay for some of their entertainment. If I pay for some of their entertainment, then they will be happy that they got to hang out with me. If they're happy they got to hang out with me, then whatever. So getting the job led to the final thing. So you can, again, it doesn't matter what you're doing. If the one conclusion leads to the next hypothesis, you can logically go all the way through that system like that. So that's the law of syllogism. We're going to be applying this quite often in the next chapters when we're writing proofs, and that's what we're going to do in chapter 1.7. So an example, a lot of talking to get to the example, but assume that each set of conditionals is true. So again, we're going to start with an assumption that we have true conditional statements. So if they're not true, it's kind of pointless if we're going to be using the law of syllogism. So we're going to always assume the conditions are true. And train yourself to recognize a conditional statement. If it says if, then it's pretty obvious. But if it's categorical, all dogs are cute, something like that. If something's a dog, then it is cute, right? So be able to create an if-then statement out of the idea that they've given you. All right. This first one says, if Kenji plays the trumpet, then he plays a brass instrument. All right. So this is our first if-then statement. Playing the trumpet, hypothesis, leads to the logical conclusion, playing a brass instrument, right? Which is true because a trumpet is a brass instrument. If he plays a brass instrument, so again, here's another if-then statement, then he is a member of the marching band. Okay, and we're making an assumption here. I don't know if all people playing brass instruments are in the marching band, but in this specific example, we're going to say that happens. Playing a brass instrument automatically gets you qualified to be in the marching band. All right, so all you have to do to verify the law of syllogism is usable is that the conclusion of one of the conditionals is the hypothesis of the other. All right, so he plays a brass instrument is the conclusion of the first conditional. He plays a brass instrument is the hypothesis of the second. So we have a P implies Q and then a Q implies R scenario here. Again, the conclusion matches the hypothesis. So our logical conditional statement we can conclude with the law of syllogism is going to be, if this happens, then this happens. So we're going to write our conditional, again, the law of syllogism, anytime it says that, the answer is going to be a conditional statement. Law of detachment, the answer is just going to be a statement. Something happens, right? But this is going to be an if-then statement. So if Kenji plays the trumpet, then he is a member of the marching band. Okay. One other thing they could do with these down the road, maybe even in this assignment, they might combine the law of syllogism and the law of detachment together into a problem like this. They might say all this stuff here, right? If Kenji plays the trumpet, then he plays a brass instrument. If he plays a brass instrument, then he's a member of the band. And then they might continue and say Kenji plays the trumpet, right? So if they go, what can you conclude by the law of syllogism and the law of detachment? Well, first of all, law of syllogism is this. We get this conditional. But then that extra piece of information to give us saying that he plays the trumpet would allow us to conclude by the law of detachment from yesterday that he's a member of the marching band. So again, they might do that too. But again, if it's just law of syllogism, you should expect an if-then conditional statement for your answer. All right, part B. If points A, B, and C are collinear and B is between A and C, then ray BA and ray BC are opposite rays. All right, so, pretty lengthy conditional statement here, but there it all is. It's got a compound hypothesis, multiple things happening. A, B, and C are collinear and B is between A and C. All right, what does that look like? A, B, and C are collinear, that means they're where? On the... A, B, and C are collinear, what does that mean? They're
all like on the same line.
On the same line, that's what collinear means. So A, B, and C are all on the same line, and B is between A and C, so I'm expecting an A and a C and B somewhere between on this line segment, right? So that's what that's describing. Then, ray BA and ray BC are opposite rays. So we have opposite rays. So, the second statement says, if, I suppose I'm doing this differently, aren't I? I use the same highlighter for the whole conditional out there, so let's do that. All right, the second conditional statement here starts with if. If ray BA and ray BC are opposite rays, then AB plus BC equals AC. All right, so that's a little shorter, but again, we have conditional statements. And again, what we're looking for is, does the conclusion of one of the statements match the hypothesis of the other one? And if I'm just going to green highlight it this time, BA and BC are opposite rays. BA and BC are opposite rays. So then, conclusion, if, hypothesis, right? So the conclusion of the first statement matches the hypothesis of the second. So the law of syllogism states very clearly that the first if leads to the final then. So if I'm writing this out, I'm going to say if points A, B, and C are collinear and B is between A and C, then AB plus BC equals AC. The nice thing about law of syllogism is the answer staring you right in the face, you just have to write it down. All right, the words are right there, just copy the words back down, but just copy the words down you need to have. If the first hypothesis, then the final conclusion, that's what you want to go with. But again, the only requirement is conclusion 1 matches hypothesis 2.